Hello everyone, I am Pranjal Markale and I welcome you to the yet another podcast of Netscribes. Today's topic of discussion would be EV repair ecosystem, an ecosystem which is in its early stage, but it is rapidly evolving landscape as the number of electric vehicles on the road continues to grow. So let me just give you the recap of this session. Today, we are going to explore the challenges and opportunities of this ecosystem. We'll understand the maintenance and cost comparison against the ICE ecosystem, learn about the concept of the second life of electric vehicles. Then we'll also be touching on how traditional workshop can adapt to become an EV ready. To uncover all the answers to these topics, we have a very special guest with us, Shubham Mishra, who is the founder and CEO of E-Vega Mobility, also known as EV Doctor. Welcome, Shubham.
Yeah,
Before jumping into the session, I would like you to please walk us through your journey.
yeah. Hello, Pranjal. Thank you for the invitation, and we are looking forward to help as many EV ecosystem stakeholders as much as we can. Through this session, I will be mainly focusing upon the ecosystem on the repair, recycling, and repurposing side of the EVs. Also, how maintenance and operation of electric vehicles needs to be done. Talking about our journey, we started from e-bikes, then we dived deeper into the battery tech. We found that there is a gap that needs to be filled on the battery diagnostics, testing, and operation side. So we started working on that. We focused upon it. We partnered with various international and national players. Uh, the result of that was EV Doctor. That is a solution that will be helping EV stakeholders for getting the diagnostics done faster in a reliable manner. And in addition to that, I would like to add that we are also working on the uh, second life of the batteries. That how we can
Right.
reduce the recycling rate of the lithium ion battery so that we can gain maximum amount of energy from the lithium ion batteries.
Understood. Understood.
Yeah.
Great. Great. Thank you. Thank you for your introduction. Without wasting any time, let me jump to my first question of today's session. Okay. So, Shubham, as we know, for the longest time, the growth of EVs was being, hindered by the factors like range anxiety and charging infrastructure, largely. However, there were many other factors. However, repair and maintenance ecosystem was less spoken. So, what do you think about it, and how is it different to repair EV versus ICE? Right, and given that because these EV components are very expensive and their failure repair and service are likely to fetch extra cost when compared to ICE. So what are your thoughts on that?
Okay, so currently the market scenario is that if you consider the total cost of ownership, and if that ownership cost is including the cost of components as well, then it lies around the ICE counterparts only, right? So suppose we take the cost of batteries also, cost of motor also, then total cost of operation or total cost of owning an electric vehicle will be round about the ICE vehicle only. Now, coming to
Okay.
your exact point that where the difference is there, where we can see the difference on the servicing part, the maintenance part, and how we can increase the level of servicing for EVs. Okay, so on the EV side, there are three major components which needs to be addressed. First one is obviously battery, that is
Right.
costing around 50 to 60% of the overall EV. Second one is the motor. Okay. And third one is the electrical components which you can see. So the major part of that electrical components will be controller. Okay.
Right.
So
Right.
we'll be touching upon 3 points only: battery, motor, and electrical components. Okay.
Understood.
Now, that clear contrast is the mechanical components. Okay, the
Right.
mechanical components get the wear and tear which they deserve in ICE vehicles, but in case of EVs, the chances are less because the overall powertrain, or you can say the overall torque speed component, is shifted on the electrical side rather than the mechanical parts. Okay, so gear
Understood.
and greasing and all that will be required in EVs also, but the amount will be very less.
Understood. Understood. So very well clear. I mean, very well explained that how just because of the talk, how the maintenance or service is likely going to shift towards which components. I appreciate it. So, given that we are talking about the repair service system, repair and service system, so uh, what do you think? How the aftermarket ecosystem of EVs is evolving? Right. Because you see, batteries are the replacement cost of the battery is, I mean, is too expensive. I mean, it is half the cost of the vehicle. So one cannot just go and replace the battery if it is subjected to failure, or it is a part of, or a pack is subjected to failure. So how it is evolving?
Okay. Yeah, so I would like to give one analogy that
Yeah.
batteries are like humans only. Okay, so if you
Yeah.
understand humans and their
Yeah.
life, then you can understand the batteries also. Okay, now if you want to increase your lifespan, okay, so you have to constantly monitor your body. Okay, you have to do the routine body checkups and all. Okay, for the same thing, we need some diagnostic tool. It can be any tool so that you can get the battery checks done periodically. Where right now in India, the scenario is that every dealer and distributor is acting as a service center. Okay,
Exactly.
but these garages, these conventional garages, they don't have any facility to repair or to even join a component that is inside an EV. Okay, so they
Right.
understand ICE only, and uh, the way they repair an ICE vehicle, in the same way they are handling electric vehicles, which should not be the case. So there need to be a system where we can increase the overall awareness of the EV so that we can repair it easy enough. Second thing is we have to standardize the practices and processes while doing the repair of an EV. And third point is we can work upon the collaboration so that like if you understand the concept of multi-brand multi-brand stores, okay, in the similar way we can have a multi-brand service centers, so which are evolving, like companies like Ready Assets, Speed Force, OP, they are working on it, and they are setting up service centers across India. So I think that is a good approach, so that existing service centers can be converted into the e-garages, and in parallel with that we can build new service centers which are focused upon EVs. Okay. So
Great.
adding to that, there are 20,000 plus dealers, EV dealers across India right now, and all of
Right.
them are right now focusing on the sales only. So gradually there will be as more EVs are sold, there will be some recalls, some servicing, some operation, some maintenance parts, maintenance
Mhm.
portions that needs to be addressed. So at that point, these dealers will be converted into service centers gradually.
Understood. Understood. So, uh, this is you explain how service centers and would collab, and what would be the role of existing service center in to become an EV ready thing. So again, I would like to go to another level. Like we have, a well established aftermarket for ICE. So like you go, there are various markets, local markets available. The dealers, distributors, and the sub dealers available are having the parts who sell the EV this ICE parts. So is that such kind of ecosystem has been developed for EVs as well, or has been still developing? and or what you can say, at what phase it is right now?
Okay. So for any technological adoption, there are three phases. Okay.
Mhm.
First one is the early adoption stage. Second one
Right.
is the peak stage, and third one is the laggard stage. Okay. So ICE vehicles are
Right.
at their laggard stage for two-wheelers and three-wheelers and four-wheelers. Whereas for EVs,
Right.
it is the still early adoption stage. Okay, there is no peak stage right now. It is still in its
Right.
infancy stage or infant stage, you can say. Right
Right.
now, the focus is upon the sales. So every new business is trying to like penetrate into the EV segment also. Okay, so they think that if you dive deeper into the EV segment, you can get the early adopter advantage or the first mover advantage. So they are
Right.
focusing more on the sales side. Whereas there are some
Understood.
players like Hero Electric and you can say Yo Bike, this battery, and some other players, Okinawa. So they have been selling electric two wheelers for a decade. So they have the knowledge
Right.
of how the service and maintenance of electric vehicles is need to be done. Okay, it's need to be done. So what I would like to add is although we are at the initial stage, but the quality of the components which are used inside an EV are not up to the mark. That's why within few years, maybe within 2 or 3 years, there will be a sudden spike in repair and maintenance of electric two wheelers and three wheelers. So such problem needs to be addressed not just from the OEM side, but also on the mid stakeholder side, where businesses can tap upon the opportunity of service, maintenance, and repair.
Understood. So great. I mean, that's great to hear. Uh, Talking about you, just I heard you mentioning that these repair or service multi. You also mentioned about the multi-brand service workshops. So these are coming into the picture, and a lot of efforts being put by the altogether by the ecosystem to set up an proper ecosystem for the EVs. So, talking about this skill set, how's the skill set readiness of the mechanics workers of these workshops, and how businesses are dealing with it? So, they are arranging a special kind of training to it, because EVs are anyways ways different from ICE. Not totally, but yet they are different, as a lot of electronics is involved in the EVs. So what you take from that?
So there are some institutes, or you can say online courses, which are focused
Mhm.
upon EVs, and they are quite involved in developing or nurturing the skills of the mechanics. Okay, so
Mhm.
I can name few of them. Autobot is there, and DIY Guru is there. So they are doing good stuff. They are enabling engineers to become more skilled on the EV side, and these engineers will then train mechanics to be EV ready. Okay, so that is the first point. Coming to the readiness part, out of 10, I think uh, I can rate 7 or 8, because still a lot of development needs to be done on the readiness part. But still, what OEMs are doing, they are onboarding dealers. They are partnering with dealers for the training program. So the dealers will be onboarding mechanics. OEMs call those dealers for some meetings and all, and then they organize seminars and workshops where they can train the mechanics they have. Okay, so around 500 to 600 mechanics, suppose an average OEM has, then they call to their factory and or any place wherever the training is need to be done, and at that point they provide some initial basics of how an EV works, what's the principle of the components which are inside an EV, battery, motor, controller, or whatever power electronic equipment uh, or the component are required. So basic level of skills is provided, but the problems which are coming are not on the usage side, but they are coming onto the quality control part of an EV. Okay. So suppose an
Understood.
OEM is not making good products, then that is not called repair. That is called manufacturing defect, right? So
Yeah.
repair is still need to still not addressed, but on the manufacturing defect side, there are many.
Yeah. Understood. Understood. So, so what's, I mean, what should the fraternity would do? I mean, what is an ideal step for an fraternity to, low down this manufacturing defects, and what are your thoughts on this? How this could be overcome? Because everyone wants to, manufacture the quality product, but somehow, somewhere, they are missing on something where no one wants to deliberately do the manufacturing defects or
Correct.
create the defect products. So where you think, what is the where is the loophole in this?
So there are two loopholes where I can see easily that due to that only there are low quality products available in the market. First one is they don't have any control on the engineering side. Okay, so either they are importing it,
Mm.
or they are outsourcing it, or they are collaborating with some other brand and taking that component from them. Okay, without getting even the basics of what product specs are there. And second thing
Mhm.
is the awareness around EVs. So I'll not blame only the manufacturer or the OEM. I'll also blame the customers. Okay, so few customers don't understand how to handle an EV. Okay,
Okay.
the partial charging. Okay, so while testing the vehicle or the battery of an uh, there is no test on the partial charging. Okay, so that can be
Okay.
included in the QC part, but on the user side, they have to make sure that partial charging doesn't happen. Okay, and
Mhm.
periodic maintenance, periodic repair, and even if any issue arises, then the customer uh, should be more lenient on taking the quality components, not just focusing upon the cost factor and simply selecting the cheaper one. Okay, so
Correct.
these problems can be divided on two sides. First one is on the OEM side, and second one is on the customer handling side.
Right. Right. So you just mentioned about the customer handling should be, customer must be more conscious while using the product like EVs. But you see, the India is a very price sensitive market, and most of the users uh, at some point of time after the free service period is being over, they don't prefer to go to the showrooms. They have local mechanics around, right,
Hmm.
where they prefer to go to those workshops. So my question is how those workshops can become an EV ready, or in fact, I would say, what if someone wants to get into this business, EV repair business? So what would be the typical cost of setting up this repair service workshop? Or the second question is, if already the traditional service workshop, how that can become an EV adapter?
Okay, so we can divide the cost in three parts. First one is infra cost, so you can include the space or the electricity and normal land and everything. Okay.
Right.
Second thing is mechanics. Okay, so we need to have skilled mechanics so that wherever battery service or component service or motor service is required, they should be skilled enough so that such problems can be mitigated. Third one is on the training part. Okay, so constant training is required so that skilled mechanics should know the newer problems also. Okay, so
Mhm.
as this industry is at nascent stage, we need to develop more skills on the uh, potential of the problems that can arise. Okay, so if these three things are taken care of, then such any workshop can be converted into EV workshop. Okay, typically these costs are around 10 to 15 lakhs. Okay, so within 10 to
Mhm.
15 lakhs, at max, I am saying, okay,
Mhm.
within 10 to 15 lakhs, normal workshop can be set up where any electric two-wheeler or three-wheeler can be tested, can be serviced, or can be repaired. But on the battery side, the opening of the battery can't be done within such workshops. So they have to obviously reach out to the battery pack manufacturers and all. Okay, for any type of battery repair. But in case of motors, the BLDC motors which are available in the market, the controllers which are already there in the market, they can be easily repaired or replaced at these
Mhm.
work. Also adding to that, uh, I'll be conscious on the supply chain also. Okay, so dealers or workshops, they need to make sure that which type of EVs are coming to such places, and depending upon that, the spare parts or the accessories or even smallest of the components should be uh, ready, so that wherever replacement or repair is required, they can easily get upon that.
Right, right, right. Understood. So, can we say that uh, ecosystem, can we divide this ecosystem into two parts? One would be just for the motors and the other components. The batteries would have a separate ecosystem. Can we
Yeah,
say that?
yeah. Because
Because
battery, yeah.
Mhm.
Tell
Mhm.
me.
Because if you can just tell us more on how battery replacement of a battery or repair of a battery pack, a module or a cell is done, and how how it is done, and what could be the typical cost of setting up that ecosystem, or maybe
Okay,
that service workshop.
okay. So I'll explain the journey of a battery. Okay, of
Yeah,
how lithium battery is made and how it is treated and how the second life happens.
yeah.
Okay, so let us start from cells. Okay, so cells
Mhm.
are right now imported from China, Taiwan, or any other place. Okay, then they are
Mhm.
assembled and battery packs are made. Either they are made by OEMs or they are made by battery pack manufacturers. Okay,
Right.
now some of the OEMs, they make it themselves, like Ether and Ola, they are making it themselves, and some are directly collaborating with battery pack manufacturers and they are getting from battery pack manufacturers. Okay,
Okay.
once this is done, OEMs focus upon the sales and service part. Okay, so initially they'll do the sales. Okay, they'll sell n number of electric vehicles across each month, and they'll see the growth across each quarter. They'll observe the year over year growth also. Okay, now once the sales is done, now dealer has to take care of the repair or any aftermarket thing. Okay. So suppose
Okay.
any issue arises on the two-wheeler owner side. Okay. So
Mhm.
typically these issues are the range is reduced, water damage
Right.
is there. Uh,
Right.
Worst case is battery fire, or you can say the thermal
Right.
runaway.
Right.
Sometimes the cells are overcharged, or they are imbalanced, so we have to balance them. Okay, so these are sometimes BMS is damaged, sometimes the enclosure is damaged. Okay, so there are various reasons due to which battery packs are damaged, and due to that the safety and performance is compromised. Okay, now they will reach to the dealer or distributor right now. Although after a few months there will be some service centers also, some third party service centers. Now they reach to dealer, distributor, or any service center. They will keep the battery with them. They'll check. They'll simply do the basic voltage check using multimeter. Okay, and I have seen one dealer using their bare hands to check the temperature of the battery. Okay, so suppose the temperature is high, then they'll
Mhm.
say that this battery is bad. Okay, so they are
Mhm.
checking batteries like they are checking the fever of any person, like any. Okay, yeah, so that is the case, and that was the euphoric moment for us where we realized that there needs to be a solution which should be built by us so that we can help the EV businesses doing the
Mm.
battery checkup and all. So they are simply checking the voltage, and then they have to figure out how we have to deal with the customer. So if you see the consumer complaints website, it will be filled with all the battery issues. Okay, so they'll be
Mhm.
fighting with the dealers, they'll be fighting with the
Mhm.
distributors or sub dealers, and dealers are helpless too. They don't have anything to check. Even their
Mhm.
OEMs have not provided enough tools and or equipment or guidelines to how to handle with these batteries. Even
Right.
during the thermal runaway thing or any accident happens, then everybody is blaming another stakeholder. Okay,
Right.
because batteries were not managed properly. Okay, so
Right.
sufficient care was not taken for the battery. Now, coming to the typical process, these dealers or distributor, they will send their batteries to these damaged or harmed batteries to the OEMs. Okay, and OEMs will send it to battery pack manufacturer. So 4 to 5 months is the time where customers don't have any battery. Okay, and dealers can have one or two backup batteries. They can't have like 100 backup batteries within their dealership. Okay, so
Right.
at that
Right.
point, managing batteries becomes very difficult, and which will hamper this the brand value of the EV OEM also. Okay, so we have to take care whether we are handling these batteries effectively, even for a slight displacement, even for
Mhm.
the logistics part. So if you, I'll tell you one interesting fact. If you want to send me one lithium-ion battery, okay, and I don't know what's the status of it, okay, and if you want to send it from Mumbai to Ahmedabad, okay, no questions are asked whether this is an explosive item or not. Okay, it comes under the category of explosive goods. Okay, but within 100 rupees or 200 rupees, you can send lithium-ion battery from Mumbai to Ahmedabad, and nobody will ask like what's the status of the battery. Not from your side, not from my side. Okay, I'll simply get it from you, and I'll simply plug it to the controller and get it ready for the initial ride. Okay, so uh, what what is happening on the Nordic regions where EVs are already in the peak stage, you can say. Uh,
Right. Right. Right.
they are constantly monitoring the batteries. They are always checking the batteries whenever it is dispatched, whenever it is arrived, and they make sure that the SOC is below 40%, 30% while
Mhm.
the battery is being dispatched. Whereas in India, people demand that it should be ready so that I can directly plug it in. I have an urgency or anything.
Right. Right. So I can see there is lack of regulation. There is lack of standardization. Uh, no guidelines are being followed at any level of the supply chain, or would say the value chain. So as an EV doctor, what are your suggestions to make this ecosystem more standardized and more one who can follow proper guidelines, so that together this adoption of EVs would increase? Because all these cases, all such incidents definitely hamper the growth of EVs, right? So it actually creates a negative mindset that whether I should still uh, go for an ICE vehicle, because EVs already have such problems. Because if you see the uh, the mistakes or the mishandling is done from either of the side, whether it is the customer side or whether it is the OEM or dealer side. So, what do you think of what an ideal process guideline should be?
Okay, so if you remove the battery from any EV, okay, then it
Mhm.
will be 70 to 80% similar to an ICE vehicle. Okay,
Okay.
okay, so it is also having a controller. Okay, even
Mhm.
any ICE vehicle is having a battery also. Okay, although it
Mhm. Right.
is for the an auxiliary purpose, but it is an EV if you only consider the battery part. Okay, So how we need to handle it on the regulation part, government is doing really good as they have introduced AIS 156, so that uh, now batteries are not dumb enough. Okay, so they need to be checked. They have to comply uh, with a lot of rules and regulations, and initially they have to get compliances on the certification part also. Okay, but
Right.
once the sales is done, who will take the responsibility of the battery? Okay, that is the primary question that needs to be answered, not just from the OEM side, but also on the government side. Uh, if you handle it like a toy car, then it will be dangerous. Okay, people are like they're simply riding an EV and handling it like a toy car. But once it is mishandled, then that toy car will be dangerous for you. Okay.
Right.
So adding to AIS 156, so government initiated it, but I don't know what was done to the policy. They started building testing houses across India. Okay, there is one in Mumbai, there is one in
Okay.
Delhi. Testing houses not for certification, but for the aftermarket. Okay, so that they will
Yes.
simply check any battery from any EV manufacturer, and they'll test it so that they can know whether the compliance is followed or not, whether the certified batteries, uh, the specs of such batteries are followed or not. Okay, so uh,
Right.
that approach was good, and they were also setting up aftermarket battery testing centers. Okay, so
Okay.
any EV owner can go to such place, get the battery tested, get the motor tested, that get the components tested, and they were to be set up by government only. Okay,
Okay.
so government will earn some money. Government will get some hand over the like the policies or the norms, and on the customer side also, they can maintain their EVs quite well.
That's great. I hope this setup or this guidelines regulation should work, and I'm hopeful that we must see a zero down to all these cases. Okay, so let's assume we have cracked this ecosystem and everything, the EV adoptions and you know this thermal runaway cases and everything is sorted now. So by this regulation or this policy which the government has initiated. So let's now discuss the second life of the battery because there are uh, lot many if you just talk about the mm, e-rickshaws or maybe her e-bikes, E2Ws, life of those batteries, the warranties which are being claimed by the OEMs are 2 to 3 years maximum. So and obviously after 2 to 3 years, let's say the warranty gets lapsed, and definitely no one going to change another to another EV, right? The E2W or whether E3W. So how can we get the second life of the battery? Obviously, no one expects or no one has very limited person might have witnessed these cases like after 3 years they have to throw the battery. So how what is the second life of a battery? How we can achieve to that?
So, firstly, let us understand why there is a warranty of 3 years only.
Yeah.
Whereas for a lithium-ion cell, typically the life is 10 years. Okay.
Hmm.
So if you take any lithium-ion cell or lithium chemistry cell, then life
Hmm.
of it will be 10 years. Okay. And that is
Right.
mentioned on the data sheet also. Uh, why 3 years? Because there are 365 days in a year, and if you take 3 years, that will be averaging out to 1,000. Okay, so if we can average out, so and right now for NMC and LFP batteries, uh, the cycle life is 1,000 to 1,500. Okay, for
Okay.
LFP it is 1,500 to 2,000. For NMC it is 1,000 to 1,500.
Okay.
Okay. So what is second life? If these cycles are reduced to 70 or 80% of the original ones, then the second life starts. Okay. So if
Okay.
you have degraded the battery uh, to around 75 to 80% of its overall capacity, then the second life will start. Okay. Now, what
Okay.
happens to the second life batteries? Uh, Two things are there. Second,
Mhm.
first one is repurposing. Okay, so these cells within the second life battery, they are checked and new battery packs are being made. Then they are used for various stationary applications. Okay, so you can say for solar backup, for any like data servers, for any type of stationary energy storage system, we can use that. And the second method of handling it is recycling. Okay, so in recycling process, the uh, crucial metals are separated, lithium being like primary of them, obviously. Okay, and that is derived from the black mass. Okay, so they are crushed, black mass is
Okay.
obtained, and right now in India, black mass is exported to other countries. Okay, and we are
Okay.
also supplying it to Indian manufacturers. So there are companies which are doing the recycling, and they are supplying black masses to Indian manufacturers as well as in the overseas market. Okay, so
Okay.
second life batteries have 80% or less capacity. They will be used for backup applications or stationary energy storage applications, or they'll be directly drawn down to the recycling thing.
Okay. Great. Great. That's nice. Okay, Shubham. So we are talking about on the battery side again. We are also witnessing and hearing more on a solid state battery side. So, what do you think when would be the when it's still in its research phase? So, when it is expected to come into the market, when it is expected to become commercial, and from from Indian market, because Indian perspective, because Indian market is uh, very much expected. They are tend to drive their vehicles for years and years. With solid battery coming into the picture, it is definitely going to increase. The OEMs are tend to offer more uh, life to the batteries, more warranty to the vehicle, to the customers. So what do you think about the solid state batteries?
Okay, so I'll not directly jump to the solid state batteries. Firstly, I'll introduce some other chemistries as well, which will come first,
Yeah.
and then solid state batteries will be there. Right now, the biggest cell manufacturer, CATL, they have built sodium ion batteries. Okay, so
Okay.
they have lesser energy density as compared to lithium ion batteries, but the safety quotient is high. So, firstly,
Okay.
they'll be explored because its commercialization phase has started, and there are companies which are selling those cells. Okay, so
Yeah.
once they are, we can say, exploited to the max, then we will see in parallel we will see the hydrogen vehicles come into the market. Okay, so
Okay.
Toyota was the first company who was betting upon the solid state battery, but right now they have shifted their whole vision to hydrogen counterpart. Okay, so
Okay.
firstly, hydrogen vehicles will come uh, in parallel to the sodium ion batteries, and then we will be having solid state batteries. Now, coming to the point, solid state batteries, how they work, they will be using the electronic state only for getting the batteries charged. Okay,
Okay.
and so just like an electronic thing, they'll be using the speed of data transfer for the energy transfer. Okay,
Okay.
but the thing is, the commercialization stage or the commercialization phase of solid state is not even in its initial stage. Okay, so
Okay.
there are no pertinent growth on the commercialization part of it or even the cellular stage of it. Okay, so if you see lithium-ion batteries in 1990s, to be exact, 1988, the first lithium-ion cell was found, and in 1990s, people started exploring it. Okay, but
Right.
the real commercialization stage was started around 2004 or 5, where Tesla also started and other companies also joined this EV bandwagon. Okay,
Yeah.
so
Yeah.
if you see uh, such journey, then you can see how much time it takes to really commercialize any technology from right from R&D to the adoption level. Okay,
Right. Right.
until these existing chemistries are explored, or you can say exploited,
Right.
will not be having solid
Yeah.
state batteries within future. Yeah.
Right. Right. So, well, that's all from my side. I have actually exhausted with my questions, and you answered it very well, very thorough, very deep. So yeah. So thank you for being here. Thank you. You took out the time for this particular podcast. Uh, I look forward to have such podcasts again with you. So thank you.